Good day. This is Karel Sanita from BSED Mod 3B. So today I will be presenting to you my geometric model named dodecastrix. So it is a 12-pointed geometric star polygon characterized by sharp intersecting vertices, evoking both mathematical precision and a blade-like or stellar radiance. So it is reinterpreted in modern usage to signify piercing angularity. So here is the model. It is a 12-pointed star. So now, let's identify the elements for the model. So for front, we have here K, A, R, E, L, O, V, 5, 6, 8, 3, and 4. So for back, we have here the star, the square, the circle, the triangle, the heart, the diamond, the crescent moon, the cross, trefoil, the quadrifoil, the ellipse, and lastly, the semicircle. So now, let's identify first its rotational and reflective line of symmetry. So for rotational, if we will do either counterclockwise or clockwise, we have here 12 rotational symmetry. And for reflective line of symmetry, we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total of 12 reflective line of symmetry. So now we have here our possible moves for front. So for K, we have to do nothing. For A, we have to rotate it 30-degree counterclockwise. For R, 60-degree counterclockwise rotation. For E, 90-degree counterclockwise rotation. For L, 120-degree counterclockwise rotation. For O, 150-degree counterclockwise rotation. For V, 180-degree counterclockwise rotation. So for 5 to 4, we can do the clockwise rotation. 150-degree for 5, 120-degree clockwise rotation for 6, and so on. So for crescent moon, we have to flip the model horizontal, flip vertical for star. For ellipse, we have to do the move from A. So here, A is we have to move first 30-degree counterclockwise rotation before we proceed to the next move. Same goes to quadrifoil, trefoil, cross, diamond, heart, triangle, circle, square, and this semicircle. So now, here is the table that we need to complete. So first one, we need to do the K star K. So for K star K, this is the original model. So, and here is the result. So if we have to do K star K, we have to do nothing. So the original result is still K. So let's put it on the table. So here, let's put the resulting element K. So for next one, we have to do K star A. So as we can see here, the original element, we start with K. And then we have to do the 30-degree counterclockwise rotation. So the resulting element is A. Okay, let's put A. So next one, K star R. So first K, our first move, and we have to do 60-degree counterclockwise rotation. So the resulting element is R. And let's put it again here. Okay, so next one is for E. We have to do again, start with do nothing. And next is, we have to do 90-degree counterclockwise rotation. So the resulting element is still E. Let's put again E. Okay, so as we can see, we are just mirroring the outer or the higher part of the table, which is the moves. So what we can do here is we just need to copy this one. copy this one to here. Okay, and so on up to here. So next one is we have to perform the operation A star K. So A star K. Now let's start with the element K, since the first move needs to be A. So A star K, A, we have to do nothing, so still it is A since we are not doing something. So for R star K is same goes there, that we have to do nothing, so the result is still R. Same goes with the back element. We have to do nothing. We are just copying the first move. Okay, like that, star star K. So if we can see, if we are performing with K, especially if our first move is K, we have to mirror the outer part of the table, or we just need to copy the second element. But if we are working with for example A star K, the K is the second move, we just need to copy the first move. Since we are doing nothing, we are not doing anything, so this has to be R, E, L, O, V, and so on. And so on. So now let's do with A star A. So A, let's start with A. And then star A. It is stated there that we need to do 30-degree counterclockwise rotation. So the resulting element is R. Okay? And let's put it sa table. A star A is R. Okay. Same goes with R. R star A. The first element, or the original element, is R, and we rotate it 30-degree counterclockwise. So the resulting element is E. So R star A. So R star A is E. Okay. Same goes with the other element, and for the back element. And so for star, again, same goes. We have to rotate it 30-degree counterclockwise. So here is the result for the table after we did the rotational movement. So next one, we have to do the other movement. So A star C is the next move. So kailangan we have to flip horizontal. So let's watch how to do it. Okay, so the resulting element after we flip the model horizontal, the resulting element is diamond. So for A star C, so for A star crescent moon rather, so A star crescent moon, so the resulting element is the diamond. Let's put it there. Alright, so after doing the horizontal or the flipping movement horizontal, here are the result. So next is we do the A star star. Here is kailangan naman vertical naman. So let's watch how to do it. Okay, so the resulting element after we flip it vertical is the semicircle. So A star star is semicircle. Let's put it there. A star star is the semicircle. Alright. Now, so here are the results after we did the flipping movement, specifically if we flip vertical. So now, let's move to the other movement. So A star ellipse. So here the movement or the command for ellipse is we need to do first the command for A. Since the command for A, we need to rotate the model 30-degree counterclockwise before we proceed to the next command. Okay, let's watch how to do it.
Okay. So let's do the command for ellipse. We have to flip or to rotate it 30-degree counterclockwise. So R. So from the right vertex of the triangle, here is the triangle. From right vertex, fold it to the left.
Okay, so the resulting element is the quatrefoil. So let's put it there. So A star ellipse is quatrefoil. Here is the quatrefoil. Since apat siya, 3, 4. Okay, same goes with the other element. So A star quatrefoil is for R, right? We need to do 60-degree counterclockwise rotation. Let's start with A. So let's watch.
So A, let's start quatrefoil. So let's do 60-degree counterclockwise, 30, 60, and from triangle, right vertex, here, fold to the left. So the resulting element is the trefoil.
Okay, so the resulting element for A star quatrefoil is trefoil. So here's the trefoil. Alright, so same goes with the other element or the other movement. Just like here, A star quatrefoil, we just need first to do the movement for E before we proceed to the other command. So here is the final result of our table. So as we can see, we already fill up the table. It is now complete. So now, it is our task to show the set of moves in the geometric model forms a group structure. So, to determine whether the geometric model satisfies the condition of a group, the following properties must be satisfied. It should be closed or the closure. It should be associative. There should be an existence of an identity element. And lastly, existence of inverse elements for all elements. So first, let's go for closure. Let's test if it is a close. So as we can see here, the elements or the results ay mahahanap lang natin within the set, right? So therefore, it is closed. Since all resulting elements remain within the set, the geometric model is closed under the operation. So check yung closure. Next one, let's test its associativity. So associativity can be confirmed by checking for 180-degree rotational symmetry in the results table. So ang kukunin lang natin dito is yung etong result lang. Okay? Hindi na natin isasama yung outer part, which is yung mga movement. So here is the rotated table, 180 degree. So ito lang yung kukunin natin, yung naka-box na red. So ito yung mas pinaayos na table for us to better perform what we need to perform. Okay? So now, ang goal natin is this table here, kailangan maging same siya dito. So, we have to do some switching, interchanging, or inserting some columns or rows. So, the first we need to do is the switching. So, for you to better visualize, hinati natin siya. So, ito, 1 to 12, column 1 to 12, and ito, column 1 to 12 also. So, let's do here. It says there that the second column and the 11th column must be switched. So here, kung ano yung color ng letter, yun din yung color ng arrow for better understanding. So, Next is also the third column, switch to fourth column, switch sixth column and seventh column, and then switch 10th column and 12th column. So for the left or the right side, again, kung ano yung color ng statement, ganun din yung color ng arrow. Okay, we have to do switching. So here is the result now after we do the switching. So now, as we can see, it is still not the same with the original structure. So we have to do more interchanging. So now, again, hinati ulit siya for better understanding. So sa left side, we have to switch the 5th column and 6th column. Also goes with the 8th column and the 10th column. So sa right side naman is kailangan din nating i-switch yung 3rd column, which is yung sa red arrow, and the 5th column. Same goes with the other arrows. Okay, now, so as we can see here again is the resulting elements after we do the switching. So by closely observing, it is still not the same with the original structure. So we have to do again more switching. So here we have to do the switch 9th column and 11th column. Like here, we have to change it, switch it. For this side, switch 4th column and 11th column, as well as 7th column and 9th column. So here is the resulting element. So again, it is still not the same with the original element. But as we can see here, if we look at these symbols, it is now the same with the original structure. So, ang kailangan na lang natin gawin is itong side na to. Kailangan itong side na to ay mag-same siya dito. Okay? So, we have to switch 3rd column to 9th column para yung or mapupunta na siya dito. Okay? So, here is the resulting element or resulting table again after we do the interchanging of column. As we can see, it is still not the same with the original structure, and we have to do again switching. So here we have to switch the 5th column and the 9th column, which is the column of 6 and the column of L. So as we can see now, the first row is now the same with the original structure. But as we can see here, hindi pa siya same with the original structure. So, after we do the switching in columns, we now need to perform for rows naman. Okay, again, hinati ulit natin siya. So, we have to perform this instructions or this switching to arrange the rows. So again, as we can see, they are still not the same with the original structure, and we need to do more switching. So now, as we can see, the row of V, we need to insert this to or between row of O and row of 5. Okay, so again, we have to do switching. So this row of quatrefoil and trefoil, both of them, we have to insert it between the row of ellipse and the circle. So here is the resulting element. So as we can see, if we look closely on the table, it is now the same with the original structure. So since to verify associativity, the operation table was rearranged by swapping its rows and columns, yung ginawa natin kanina. So, after these transformations, the resulting table matched the original structure exactly. Right? Kung makikita natin, same na silang dalawa. So, this confirms that the operation is associative. So, check ang associativity. So, next one is let's identify if there is an existence of an identity element. So to determine the identity element from the operation table, we have to examine both rows and columns corresponding to each element. So the identity element is found where a particular row and its corresponding column exactly mirror the original element or the ring. So the identity element is thus located at the position where this row and column mirrorings coincide. So kung saan sila nag-intersect. So for you to better understand, here is the visualization. So as we can see, the results that were boxed na red, okay? At saan sila nag-intersect? Dito sa K. Dito sila nag-intersect sa K. So, the identity element is K. The presence of an identity element is confirmed when a row and a column in the operation table exactly match the element or the ring along the table's margin. So, in this case, their intersection identifies the identity element, which is the element K, since dito sila nag-intersect. So, check natin ulit yung pang third condition, which is the existence of an identity element. So lastly, we have to find the inverse elements for all elements. Since na-identify na natin kung ano yung identity element, makikita na natin ngayon, to find the inverse, we need to look for the K, each column. So here are the K's. So to check the inverse, look along its row until you find K. So, for example, here is the K. So, the column header is its right inverse, and the row header is its left inverse. For example, the inverse of K is K. Okay? And the inverse of A, since here is the identity element, let's look at the column header. So K, identity element here. Let's look here. So A, the identity or the inverse element of A is 4. Okay, same goes with other elements. So here are the list of the inverse elements for all elements. So as we can see, each element has an inverse. So check again yung existence of inverse elements for all elements. Therefore, the geometric model form a group structure since it satisfies all the condition. It is closed, it is associative, it has an identity element, and the existence of inverse elements for all elements. Therefore, it is group. And thank you for listening. And let's see you again for the next episode.